continue with our previous video. So we will demonstrate how affect the sample size and how to quantify the effect of the sample size. So we're still doing different sample size to run 10,000 times. But after each sample size, we got the histogram. We also print more information. We will print the sample size, population mean, average of the sample size, average of the sample mean, and the population standard deviation, and the standard deviation of the sample mean, and also about their ratio. So the most important thing here, we want to see how the standard deviation of the sample mean will affect from the sample size. So earlier when I run the sample size 100, so please make sure if you are missing this delayed SD, you need to add that value to before you run this function. Okay, so the first thing, we already have the sample size 100, but also since the 400 and 900 will run for a long time, so I will run first, and when we wait for that, I can explain. Okay, so let's see here, we do the first one for the sample size 100. Okay, 400 is ready, so the same thing, let me run the 900. So 900 will take a while, so that's why I want you guys, if you want, you can run first, then you go back to see the result. So we see here the sample size is 100. Still, not too bad, right? They still kind of have the sample mean still have similar to the bell curve, the normal distribution. But one thing is we can see their interval is about 5 to 30. So we can visual to see the center. Still you see about 16 something. But the standard deviation, the same thing, we can kind of like know it's about here. But also we do have the information display. Okay, so what we find is when we talk about the sample size 100, if we only compare the population mean and the average of the sample mean, ooh, they are very close. You see they are even close to the second decimal place. So now we see the standard deviation. The population standard deviation is high, is about 39.48. But the sample standard deviation for the sample mean only 4. And also we can see if here is the average, 4 is about here. Okay, so that's earlier we see if we did a bell curve, yeah, it's about here. Okay, so the ratio is about almost 10. Okay, so continue, we see the 400. When the sample size become 400, again, the population mean is very close. You see still they are close. Even just go to the second decimal place, it's only 0.01 different. But the standard deviation for the 400 even drop down even more. Okay, so that's almost less than 2. But again, we see here, we see the distribution. 400 earlier, we see they already have the normal distribution curve. But also you see earlier for the 100 sample size, the interval is about 5 to 30. But for 400, they not even 10 and 22. So that's we say they are become interval, the bell become narrower, for the size become bigger. Since they become narrower, just like earlier we guessed, so they may affect the standard deviation. Because if they are narrower, you see the bell will be sharp going down, then smooth out. So the standard deviation about here. Because you see earlier we say here is the average, right? So then the standard deviation, right, is about 2. And also that's we got the value. And we see here the ratio is about 20. Continue to see 900. So 900 we are expecting what? We are expecting the average should be similar to the population. And the interval, the width should be narrower. So that means the standard deviation will even be smaller. So then we see the sample size 900. Right, so the population mean and average of the sample mean, the same. They close to second decimal place, even just 0.01 different. But the standard deviation will be a lot big different. So then standard deviation for the sample size 900 is about 1.3. Because here we can see, right, they are still bell curve. But because the bell become narrower, so that's why when they going down here, the kind of inflection is like about here, then they become smoothed out. So then we see here, they got us, our answer is 1.3. And the ratio is about 30. So from those three different distributions, what information you get? Yeah, from these three, we find out, look like sample size 100 is big enough. The population mean is very close to the sample mean. But continue with the sample size become bigger, 100, 400, 900. They both have very good estimation about the population mean. But as the sample size become bigger, the bell become narrower and the standard deviation going down. But also, you may curious about why we have the ratio here, right? So if you see that the ratio for size 100, the ratio is 10. The sample size 400, the ratio is 20. The sample size is 900, the ratio is 30. So not sure you find out 100 square root is 10, 400 square root is 20, 900 square root is 30. So that's why we get here. So that we find actually is here, the square root got our answer. So the standard deviation divided by the now again, the 39.48 is the population standard deviation, right? So then actually this one is the sample mean standard deviation. So then we find out standard deviation from this population divided by the standard deviation for the sample mean will close to the square root of the sample size. So that we want to show you more information by the central limits theory. From the variability of the sample average, the distribution for all possible sample average of a given size, we saw the sample size, is called distribution of the sample average. We approximately get an empirical distribution. And also from earlier different sample size we try to plot, we find out the center equal to the population average from the empirical distribution. And the standard deviation from the sample mean will equal to population standard deviation divided by the square root of the sample size. So what does that mean? Of course, we may not be able to know the population standard deviation, right? But one thing is, we can get the sample size. We can get our sample standard deviation of the sample mean. Then we can get the population standard deviation. So that's another information we get from the central limit theorem. To help you understand better, we have two discussion questions before we end this lecture. So please make sure you will spend time to talk with your classmates and think about the answer. So the first discussion question is, a city has 500,000 households. The annual income of this household have average. So this one is population average, since we say we know that. So the population average is 65,000 and standard deviation is 45,000. So the distribution of the income is what? Okay, so make sure you pause the video before we go over that. So I'm assuming you already discussed with your classmate, right? Okay, so what is the answer? If not, make sure you pause the video, discuss with your classmate. So the answer is C, right? One thing is because this one is population average and the population standard deviation. So we don't have any information about how the population distribution is. So that's why they may be close to normal, maybe not. We cannot tell from the information here. Okay, so that's our first discussion question. So again, central limit theorem, here we can kind of have updated information we handle complete. So when we talk about the CLT, the sample size needs to be large enough and drawn at random with replacement, regardless the distribution of the population. You see, that's why earlier, is that they are population distribution. We don't know just from the average and standard deviation. We need more information to know the distribution. So no matter what kind of distribution of the population, okay, your probability distribution of the sample average. So that's mean the empirical distribution from the sample average, from many sample average. There will roughly be normal distribution, bell curve, well symmetric. Then the population mean will equal to the mean of the sample average. And the population standard deviation divided by the square root of the sample size will be the standard deviation for the sample average. So from here, that's why you have your last discussion question. So this discussion question, we told you a population has an average of 70. Standard deviation is 10. So which of the histogram below is the empirical distribution of average 10,000 random sample of size 100 drawn from the population? So which one? And explain why. Yeah, make sure you pause the video and discuss with your classmates before you see the answer. From this, since the sample size is what? Is 100. So that's why the most important thing we know here. Sample size is 100. So then the standard deviation for this sample average will be the sample size square root. So 100 is 10. So using the population standard deviation, that's 10. Divide by square root 100. So the new standard deviation for the random sample should be 1. Okay, so that's why here we need to find which standard deviation is look like 1. So they all are normal distribution. They are all in the middle. But one thing is, you can see most of them, all of them actually, they have the bell curve like this. So we kind of know the turning point is about here, about here, about here. But from A, if they are here, they are like 70 minus almost 60. So the SD is 10. So from this one to here, the inflection point is about here. So that's 69 subtract from 70. So standard deviation look like 1. So this one is the same thing, the inflection like here. But that's about here. So that's why the standard deviation is 68 subtract from 70. So this SD is 2. So that's we got the answer is B. So that's our last discussion question. So this discussion question, we can ask you which one is the sample size 100. So the same thing actually, I can also ask you which sample, which distribution have smallest sample size, or which distribution have the largest sample size. So then you also can get information from there. Okay, so that's our last video. So then that's our lecture 27. So after this one, you can work on your lab exercise 8. So that's the lecture 27. So we will continue the lecture 28 in the next video page.